Here we go. We have a question: maximum candies allocated to k children. So you are given 0 index integer array candies. Each element in the array denotes a pile of candies of the current element. You can divide each pile into any number of subpiles, but you cannot merge two piles together. You are also given an integer k. You should allocate piles of candies to k children such that each children gets the same amount of candy, and each children can be allocated candies from only one pile, and we know that we cannot merge two piles together, so children can get the candies from one pile only, and some piles of candies may go unused. So that's totally fine. We need to find out the maximum number of candies that each children can get. So suppose we have given this uh, array and we want to distribute this much candies into 3 students, and each students get same number of candies. So can we distribute one candy? Yes, we can distribute one candies. Can we distribute two candies? Yes, we can distribute two candies. Then this first pile can be broken down into two, and one. So one is unused. So two students take two candies from this pile, and third children will take candy from this. So two is also fine. What about three? First will pick 3 from this, second will pick 3 from this, third will pick 3 from this. So 3 will also work. Will 4 work? So first children pick 4 candies from this, second and third children pick 4 candies from this. Yes, it will work. What about 5? First children will pick 5 candies from this, second children will pick 5 candies from this, and third cannot pick from this pile, but third can pick from this pile. So 5 will also work. What about 6? So first children cannot pick 6 candies from this, first children can pick 6 candies from this. Now it's on to the second children. Second children will pick 6 candies from this, and third children will remain empty. So third children cannot pick any candy. So this will not work. 7 will also not work. 8 will also not work. So the maximum number of candies is 5 only. So the answer is 5 in this case. And in this example, we want to distribute 11 candies. We want to distribute candies into 11 students. But if we give one candies, still only 7 students will be fulfilled, and 8 9, so 11 students will not pick any candies. So the answer is 0 in this case, right? So let's build the approach. So question is pretty straightforward. 1 for 1 it will work, 2 it will work, 3 it will work, 4 it will work, 5 it will work, 6 not work, 7 not work, 8 not work. So we will apply binary search in this case. So we will pick the maximum between these. Why maximum? I will tell you. But first of all, let's pick L as 1 here and R as maximum. Maximum is 8 in this case. Then I will find my mid. Mid is this, right? So let me change the color. My mid is this. So this is my mid. So this is my mid. Can we distribute 4 candies? So let's change the topic. We want to distribute 4 candies, right? So we want to distribute 4 candies, but so let's figure out how many students will get 4 candies. So if I have given this array, so we want to distribute 4 candies. So from this pile it can distribute into one student. From this pile it will be divided into 2 students. From this pile it will be divided into 1 student. So students, 5 students can be fulfilled. Okay, so students fulfilled is 5, which is greater than this, right? So this is a valid answer. If 5 students can be fulfilled, or k students will be fulfilled, so it means mid will work. Mid will work, right? So this will work. It means till here all the values will work. We want to find out the maximum candy. So let's store 4 for now and change our L to mid plus 1. Our L is now here. L is now here and R is on to 8. So my mid will be, so 13, my mid is here. Will 6 work? So let's check how many students. So between this pile, if I will distribute 6 candies, so how many students will be fulfilled? So no student from here because we want to distribute 6 candies. One student from here, one student from here. So only 2 students will fulfilled, but we want to fulfill 3 students. So this will not work. I am sure mid will not work. So let's change the R. My R is here. R is on to 5. Mid is also 5. So let's figure out for 5. So one student will be fulfilled from here, one from here, one from here. So 3 students will be fulfilled. And we want to fulfill 3 students only. So 5 will also work. Or greater than 5 will be work. So let's change the L. My L is here. My L is here. L is on to 6. Now L surpass my R. So my answer is 5 only. So in this case, answer is 5. Let's talk about this test case. 1, 2, so 1 to 10. 1 to 10 we have a range. My L is 1, my R is 10. So now you will get it why we need to take maximum. So let's first find the mid. Mid is L plus R 11. 11 by 2 is 5 only. So how many students will be fulfilled if I distribute 5 candies to each student? So no, 0 from here, 0 from here, 0 from here, 0 from here and 2 from here. Okay, so only 2 students will be fulfilled, but we want to fulfill K students, which is 5. So 5 will not work. I am sure 5 will not work. So let's store mid minus 1. Okay, so I am pretty sure that my 5 will not work. So let's figure out for let's change the R. And here initially my answer is 0. It means no students is fulfilled. Why take 0? So let's suppose my K is much bigger value and the summation is less than 500, right? Summation is right. Summation is less than 500. So according to test case 2, so 0 candies will be distributed, right? So we cannot distribute. So that's why I have to take answer as 0. Let's continue. So 5, my mid is 2. How many students will be fulfilled? 0, 1, 1. Then 2 students from here, 5 students from here, right? So which is greater than my K value? Which is greater than my K value? Yes. So my mid will work, means my 2 will work, or the answer is greater than 2, or the answer is greater than 2. My mid is 3. How many students? How many students will get 3 candies? 0, 0, 1, 1 and 3. So 5 students. So 3 will also work. 3 will also work, or the answer is more than 3, greater than 3. So what about 4? My mid is 4 only. Let's calculate for 4. 0, 1 and 2. So 3 students will be fulfilled, but we want to fulfill 5 students. So 3 will not work. So I am pretty sure mid will not work. Answer is less than mid. Answer is less than mid. Now my L surpasses my R. Answer is 3 in this case. Yes, 3 is the expected answer. If we want to, so 3 candies will be distributed at max to 5 students. 3 candies. So I am again repeating. 3 candies distributed at max to 5 children. To 5 children, right? So at max we can distribute only 3 candies. So 0, 0, 1, 1 and 3 from here. Is 3? Yes, 3. So that's how this will work. I will broken down my pile. So how to get this value? So it's very easy. If I want to find out for mid, I will just divide ARR. I divide mid. So it will give me number of number of piles. So I have broken down my pile. So suppose in this example I want to figure out for mid 3. So I want to figure out for mid 3. So for 3, how many students will be fulfilled from this pile? If I can give 3 candies, how many students will be fulfilled from this pile? So 10 divide 3, which is 3. Only 3 students will be fulfilled. Yes. So this will give me the number of students will be fulfilled. Right. Then, so let's code this. Code is gonna be very simple. My L is 1. We will start from 1. We are not calculating for 0 because we have already considered 0. I will take my answer as 0 and R will be my maximum between candies. My answer is initially 0. Then left is less than or equal to R. Then let's find for mid. L plus R minus L by 2. Then let's find out for how many students will be fulfilled. So let's figure out for apply and let's say distribute candies and give candies and give mid number of candies. First let's complete the distribute function and maximum function. Distribute this much candies and this is long, so this can also be long. This will also be long. Number of students, number of children. So let's say 0. Let's iterate in array and children plus equal to I divide candies. I am distributing mid number of candies. This will be children's and load also complete for maximum. I want to figure out the maximum value. Right. So if children is more or equal to k, it means we can distribute into k children's or more than k children's. So this will work. So I am sure mid will work or the answer is greater than mid because we want to distribute maximum number of candies, right? So if this not work, let's go on the left hand side. Just return the answer. Let's run this. Working fine. Let's submit this. Yes, working fine. Let's discuss about the time and space complexity. So we have this while block. This while block is just binary search. So what's the range? The range is the maximum value. So it will be log of maximum. And inside this I have this distribute function. This distribute function will run for order of n. So n multiply log of maximum. So this is my time complexity. What about space? So I am not using any space. Space is constant in this case. And thank you all for watching.